All right, so to start off this section, we're going to do a little bit of review of some ideas that I know you've seen in the past from trigonometry, some definitions mostly. So trigonometry, what is trigonometry? It's the study of, and you see the beginning prefix here, it's the study of triangles as the basis for it. It has uses in navigation, building, engineering, various things. I mean, we talk about navigation. Back in ancient times, Greeks, Babylonians, things like that, used the stars, used trigonometry to help record locations of stars and also to tell where they were going. We use trigonometry studying scientists do, studying DNA, and we can also do things like calculations that otherwise would be difficult to do, like the height of a mountain. So just some basic uses of trigonometry. These are, and I mentioned them in class, the 6 trigonometric functions, the ones you're familiar with. Sine, cosine, and tangent. The other functions, and these are the main functions, those 3, the other 3 are what we call co-functions. You see co as a prefix, you think it goes together with something else. Each of these co-functions, cosecant, secant, and cotangent, gets paired up with or kind of is related to one of your other basic trigonometric functions. So we have these abbreviations, sine, cosine, tangent, cosecant, secant, cotangent, so that we don't have to write out these words fully. So when we talk about 6 trigonometric functions, these are the other 3. So when we have these functions, sine, cosine, and tangent, we'll start with the definitions of them and realize this theta means what angle position you are at. If you look at our right triangle, so we're talking about trigonometry, basic trigonometry is always based off of right triangles. Sine, cosine, tangent, their definitions are based off of looking at a triangle from this particular angle. If theta was up by angle B, that would be fine. We'd put it there. No big deal. Sine, cosine, and tangent are ratios. And hopefully, when I put this up top here, it looks familiar to you. This is SOHCAHTOA. This is a tool to help us remember what sine, cosine, tangent, what ratios they relate. So we talk about right triangles, sine of theta. We see sine of theta says SOH. So the S stands for the sine. The O and the H tell you what ratio the sine of the angle is equal to. So the sine of that angle is equal to the opposite side over the hypotenuse. So the O, the A, and the H stand for what sides of the triangle you're talking about. So if we're starting at angle A, the sides that's opposite of angle A would be across. So angle A across from angle A would be the side that's opposite. The hypotenuse is going to be the side that's the longest that this right angle is pointing at in the right triangle. It's like an arrow pointing you to the hypotenuse. And we see A, what does A stand for? So O is opposite. H is hypotenuse. A, the side we're missing, A, so side B here must be A. A means adjacent. So when we write the sine of theta, sine of this angle, we want to use the values that are on the opposite side. So A in this case, no numbers, and the hypotenuse. A divided by C is the sine of that angle. So if we use SOHCAHTOA, the SOH tells you what sine uses as its ratio. Cosine, so CAH, C-A-H, tells you to use, so we're doing cosine, we're using the adjacent side, the A, divided by the hypotenuse, the H. So the adjacent side, we said, was letter B, and the hypotenuse still is letter C. So the ratio cosine of that angle is B, whatever side B is equal to, over C. On the last one, tangent, so that's where the TOA, the last part, comes in our mnemonic device. It's the opposite side of the triangle divided by the adjacent side. So the opposite side from that angle would be A. The adjacent side would be B. So those three ratios, we define them using SOHCAHTOA as our helper to figure out what ratio we are talking about. So when our right triangle, if we're talking about sine, so I have written on the left side the sine, cosine, tangent, now we have the cofunctions that go with them. When we talk about the cofunctions, these cofunctions are linked together. Sine is linked with cosecant. Cosine is linked with secant. And tangent is related with cotangent. The way I always remember this, tangent and cotangent obviously are related. I mean, the names seem to say it. And then I look at the first letters and I remember that the first letters that are linked are not the same letter. So sine goes with cosecant because those are different first letters. The way these two are linked is the cofunction is actually the exact same values, but we use actually the reciprocals. So sometimes we want to talk about, instead of the ratio of the opposite side to the hypotenuse, we would use the hypotenuse over the opposite side. So reciprocal means take that ratio and flip it. So the secant would be flip the adjacent over hypotenuse, and the cotangent would be adjacent over opposite. There's going to be lots of things you can do with this when you get into pre-calc and you talk about trig identities and things of that nature. But for right now, we're kind of just identifying what the 6 trig functions are. So if we want to actually utilize these in a actual problem, evaluating the trig functions with some numbers. So if we want to evaluate the 6 functions, sine, cosine, tangent, cosecant, secant, and cotangent, we want to take sine, the function of theta. We want to look like, and so when we say the angle, it's just telling us where's our perspective from. We want to take the sine, cosine, tangent, all these functions from this angle. So that helps us identify 24 is our opposite side, 7 is our adjacent side, and 25 is our hypotenuse. So if we use SOHCAHTOA as our guide, that helps us do our ratios. So sine is the opposite side over the hypotenuse, so 24 over 25. Cosine, so CA-H, so I'll put the letters alongside here. AH, so the adjacent side goes in the numerator, the hypotenuse goes in the denominator. And TOA, the opposite side is 24, the adjacent side is 7. So definitions of these, that's where SOHCAHTOA comes in. When you're doing the cofunctions, the easiest way to do it is find the sine. So find the 24 over 25, and it's just the reciprocal. Secant goes with cosine. The secant is the reciprocal. Oops, sorry, that was 24, not 25. The secant's the reciprocal, and the cotangent's the reciprocal, 7 over 24. So notice, even if we took these with a calculator, each of these happens to have a different value. There are no repeats here. These are individual values. It's not often, although it can happen, that the sine, cosine can have the same values, that different values can be equal here. But those are your 6 trigonometric functions and how to define them. So the power behind doing this kind of work with the trigonometry, and this is why we actually define these different ratios, is that we can use these ratios on specific angles, not just particular triangles that we create. And the thing about it is, when we look at these triangles, so all of these triangles have this angle that's 37 degrees. We take the sine of each of these different triangles. So this would be so opposite over hypotenuse, 6 over 10, which reduces to 3/5. The second triangle, sine of 37, opposite over hypotenuse, 3 over 5. The third triangle, 37 degrees, 1.5 over 2.5, which is the same as 3/5 or 0.6. Doesn't matter what kind of triangle you have, you're always going to have, if it has a certain angle measurement, all of these triangles are similar in that they have the same angle measurements. You're going to have the exact same ratios. So the ratios are the key. And the truth of this not only works for sine, it's a particular acute angle. Any acute angle you choose always gives the same ratio sides. So it doesn't matter which one you do, sine, cosine, tangent, cosecant, secant, or cotangent, you get the same ratio if you're using the same angles. So this is the brief intro, and we'll do much more with trigonometry from here on out.